Hello, welcome to the Ohio DOT training for the Multimodal Design Guide, or MDG. This video is the second module of a 13-part training series and focuses on Chapter 2, Multimodal Planning and Design Scoping Process Guidance. My name is Mariel Coleman of Tool Design. I served on the consultant team for this guide and will be walking you through Chapter 2. In this chapter, we discuss context-sensitive design and the need to plan and design projects that respond to local circumstances and priorities. The tools, documents, and other ODOT resources needed to guide project development and scoping are discussed in this chapter, as well as various multimodal planning approaches and analytical tools helpful for practitioners to make informed planning and project scoping decisions. Additionally, this chapter can be used to evaluate facility feasibility and assess alternatives. There are several policies and plans that serve as the foundation for pedestrian and bicycle project planning and implementation. These are summarized in the MDG and include federal regulations, accessible facility requirements, and statewide plans. Briefly, federal regulations require state DOTs and MPOs to consider and include bicycle and pedestrian transportation facilities in their engineering and planning activities. For accessibility, ODOT has adopted the PROAG as the governing document for accessible design within ODOT's public right-of-way, with one exception. ODOT provides alternative guidance to PROAG for pedestrian-activated signals at multi-lane roundabouts. For guidance on this, please see Chapter 9 for more information. In addition to these policies, transportation professionals should also be familiar with ODOT's statewide bicycle and pedestrian plan, Walk Bike Ohio. Walk Bike Ohio sets forth a vision and key goals to guide Ohio's investments in multimodal infrastructure and programs. All projects, alternative analyses, and processes impacting bicycle and pedestrian transportation should be developed in alignment with the project's purpose and need statement, community desires, and consider these statewide bicycle and pedestrian goals. There are many simple and cost-effective ways to integrate or improve Ohio's non-motorized transportation system by including pedestrian and bicycle accommodations as a part of ongoing roadway projects. Considering and addressing the needs of all roadway users is particularly helpful in planning level efforts that take place before a project gets funded and moves into the project development process. However, there are still opportunities to include pedestrian or bicycle accommodations throughout all phases of the PDP. Once a project has moved to the PDP stage, they may include a feasibility study and alternative analysis. The same guidance that can be used to evaluate facilities at the planning stage can also guide the analysis of multimodal facilities as a part of those project efforts. Understanding the needs of pedestrian and bicyclists within plans and projects is important to both address deficiencies as well as to take advantage of opportunities in our transportation system. It's also best done when we work at the network level, as we can ensure that what we're developing is a connected system and not one with major gaps. Implementation of connected bicycle and pedestrian networks takes place typically through two avenues: the identification and development of standalone projects, as well as the integration of accommodations within ongoing roadway projects, as mentioned earlier. Having a plan helps to achieve multimodal goals and prioritize key community projects. Where plans are unavailable or do not consider the needs of pedestrian or bicyclists, that's where Chapter 2 comes in and can be used to determine if and what type of pedestrian or bicycle facility should be provided in a project during the planning stage. As I mentioned before, by considering the potential need for pedestrian and bicycle facilities early in the process, projects can be programmed and funded appropriately. We're going to discuss how to select appropriate facilities later in this module. Designers and planners should also be aware that ODOT hosts a variety of planning resources, which are summarized in this chapter. Once projects are programmed and funded, they then move through the PDP as shown here. Planning within the PDP phase should not be confused with the type of planning activities I discussed on the previous slide, which occur much earlier. In the planning phase of the PDP, a project's purpose and need statement is developed, and it guides the project from development through construction. A well-defined and well-justified purpose and need statement should clearly define the primary and secondary transportation needs. These needs typically include safety and congestion for highway projects and should also include the needs of people walking and biking. A good purpose and need statement will help make decisions during activities such as an alternatives analysis. ODOT's vision and goals for walking and biking are stated in Walk Bike Ohio should also be used as a guide at this stage. Other key resources that could help inform this stage include the statewide active transportation demand and need analysis available in TIMS. So how do we determine if there is a need for pedestrian or bicycle facilities? And if there is a need, how do we determine what we do? Assessing the context of the project area is the first step in that process, as it informs us what types of trips and users we can expect to be planning for. The Multimodal Design Guide identifies locations and land uses that, if present, indicate there may be a need for walking and bicycling facilities. This comes to play again in the subsequent chapters of this guide. The Multimodal Design Guide is adopting the AASHTO context classes, which represents an expansion of ODOT's current context classifications. This expansion includes the addition of rural towns. In Section 5 of this chapter, the selection of appropriate pedestrian or bicycle facilities are discussed. The decision to provide a walkway for pedestrians should be based on land use context. The Multimodal Design Guide describes this in more detail and lists many scenarios to consider providing pedestrian facilities. This table from the guide provides recommendations for sidewalk and walkway types for various land use context classifications. The guide also describes other signs that may indicate the need for pedestrian facilities. Crossings are also an essential part of the pedestrian network. This section provides recommendations for crossing treatments and locations based on context. As you're aware, crosswalks exist at all legs of an intersection, whether they are marked or unmarked. However, as traffic volumes approach 9,000 vehicles per day, vehicle speeds exceed 30 miles per hour, or the number of travel lanes to be crossed exceeds 2 lanes, the rate of motorist yielding on the uncontrolled approach drops significantly, which can create crossing challenges and safety issues for people walking. The Multimodal Design Guide states that in these instances, designers should consider enhanced crossing treatments at currently uncontrolled intersections or at mid-block locations where the distance to signalized crossings exceeds 600 feet. This is another area where understanding the context of your project, such as the presence of transit stops or pedestrian generating land use, may require a detailed review or study during the early phases of the project. For bicycle facilities, this section starts by identifying conditions under which a bicycle facility should be provided. Some examples of this include if the project is on a U.S., state, regional, or local bicycle route, or if it connects to an existing bikeway, or more specifically, between existing bikeways and could address a gap. Once it has been determined that there is a need to accommodate people biking, bicycle facility selection is the process used to determine the appropriate facility type based on context, traffic conditions, and a target bicycle user profile. I'll speak more about this in a moment. The Multimodal Design Guide provides information on how to select the appropriate facility, adjust it based on context, and what to do if the preferred facility is not feasible. This flowchart shows a representation of this process, and we'll be starting at this point identifying the desired bikeway type. As I mentioned earlier, bicycle user profiles are a part of the facility selection process. For bicyclists, there are 3 bicycle design user profiles. Typically, in more built-up contexts, our design user is the interested but concerned bicyclist. This is due to the density of destinations in these areas, allowing for more people to take more short trips by bicycle. Note that when we're designing for the interested but concerned, we design for everyone. By comparison, though, when we design for the highly confident bicyclist, we're only accommodating a much smaller percentage of the population. So designing for the interested but concerned user, we design for all groups shown here. For the highly confident, we are only designing for that group. In rural contexts, those areas between built-up areas, our design user is typically the highly confident bicyclist, as the trips in these areas are more often recreational and not utilitarian due to the distance between destinations. The context of the area or presence of a connecting bikeway may affect which user we're designing for on a particular project. A reminder that these are just assumptions and a good starting point, but may need to be adjusted for your specific project. The guide provides 2 charts which together provide recommendations for all land use contexts based on these assumed bicycle design users. Let's take a look at the first one. In this chart, the design user assumption is the interested but concerned bicyclist, and it applies to city, small town, and suburban roadways based on our context assumptions. As you likely know, the primary contributor of stress for people traveling by bike is exposure to high motor vehicle traffic speeds and volumes. On this chart, speed is covered on the x-axis and volume on the y-axis. Ultimately, the chart provides guidance on which kind of bikeway would be suitable for the majority of users based on motor vehicle volumes and speeds. As you can see on the chart, if you have a higher speed roadway and a higher volume, then you need a design that provides more separation, such as a separated bike lane or shared use path. On certain low speed and low volume roadways, it's possible for a shared lane to be comfortable for the majority of people interested in biking. Here's an example of how we can use this chart. Let's say that this street is approximately 30 miles per hour with 4,800 ADT. And if we draw the lines on this chart at the intersection, we can see that the preferred bicycle facility type is a bicycle lane. Let's peel back the curtain a little bit more though on this, because one common myth we hear is that this chart is too heavily skewed towards shared use paths or separated bike lanes, and that you'll never be able to build these facilities everywhere and make bicycling a real option. The chart we saw on the previous slide is based on an analysis called the level of traffic stress, which takes into account a lot of different roadway factors beyond just speed and volume. You can apply that analysis to a network to determine what streets today are comfortable to bicyclists versus where the gaps and barriers are in your network. This is often the first step for larger communities. The results for the example map on the slide are similar for most communities. Many streets today are likely low-stress streets and need little to no improvements to make them comfortable for bicycling. It is the handful of yellow or red streets shown here that are creating barriers to having a low-stress, connected network for community members to do their day-to-day activities via bike. A community can layer this map with a map of important destinations to determine which streets are important to target a bikeway facility along. So with this in mind, know that when you're creating a bicycle network, it will rely on a variety of bicycle facility types, whether that's using existing lower stress streets to make connections, like the image on the right-hand side, or addressing those higher stress roadways by adding improved facilities like the image on the left-hand side. Many connections can be made through existing streets that are slow and low volume, and keep in mind that traffic calming can be used to help where needed on these streets. The previous chart focused on cities, small towns, suburban roadways, but what about rural roadways, or those locations in between those built-up areas? As we mentioned before, the typical bicyclist on roadways in rural areas is the recreational bicyclist, who often fits the highly confident or somewhat confident category. Shared lanes, paved shoulders, and shared use paths are appropriate bikeway types in these rural contexts. The second chart in the Multimodal Design Guide provides guidance for selecting the preferred bicycle facility based on volumes and posted speeds in rural contexts. We don't expect families to ride along rural roadways, with some exceptions. If there are parks, schools, or other regional draws, then we would go back to our first chart and use the interested but concerned design user as our design user assumption. Similar to our previous chart, motor vehicle speed and volume are still important factors for determining a safe and comfortable bicycle facility in rural areas. The x-axis shows speed and the y-axis shows volume. Ultimately, as the traffic speed increases and volume increases, wider shoulders or even a path is needed to accommodate the assumed bicycle design user in these areas. So let's check back in on where we are in the process. We just worked through how to identify the desired bicycle facility. Now we're ready to assess and refine that decision. There are a variety of conditions that may indicate the need for greater separation between motorists and bicyclists, which could increase the width of the bikeway or materials used in the buffer. For example, if there are a significant amount of driveways or a lot of known delivery services in the area, you may wish to consolidate driveways or add different buffer treatments to ensure that there are not conflicts between those delivery services and people riding along the bikeway. When constructing new roads, bikeways should be built to the recommended minimum dimensions rather than constrained dimensions. For retrofit projects, it may be necessary to evaluate options that reallocate existing street space or use minimum or constrained dimensions. Listed are some of the strategies for reallocating roadway space to accommodate a bikeway. These are also discussed in more detail in Chapter 7 of this guide. Finally, after exhausting all strategies, if the preferred bikeway cannot be provided, the Multimodal Design Guide also provides recommendations for selecting the next best bikeway type or how to potentially accommodate the target user through parallel routes. In Section 6, we discuss public engagement. All of the tools described in this chapter contribute to the planning process. However, no tool is a substitute for public engagement. For a project to serve a community, a diverse cross-section of people must guide the planning process. A blended approach that employs more traditional engagement strategies and more innovative methods is often the most effective way to gather a deep and diverse set of perspectives that will ensure strong community support for the project. The demographic characteristics of the participants in the public engagement events should reflect the demographics of the community being served to ensure the full range of needs of the community are being met and that the planned outcomes reflect them. ODOT's Active Transportation Plan Development Guide lists important groups to target as well as strategies beyond traditional engagement methods. It also has a chapter dedicated to specific community outreach strategies for understanding the unique needs of people walking and bicycling. Public engagement should occur throughout the life of the project, and practitioners can refer to ODOT's public involvement process for more information on how to engage the public. The final section of this chapter briefly describes analyses that can be used during preliminary engineering and feasibility studies for a project area to evaluate the needs and potential alternatives. These analyses are listed on the slide. For additional network level planning resources, transportation professionals should refer to ODOT's Active Transportation Development Guide, Chapter 5, Assess Existing Conditions. An image of the Active Transportation Plan Guide is on the slide, and this is housed on ODOT's Active Transportation webpage. Thank you for watching this video covering Chapter 2 of the MDG. For other chapters, please see the other videos in this series.